So imagine an AI that doesn't just suggest you lower your prices to beat a competitor.
Right.
It doesn't just, generate a neat little report for you to read.
Yeah.
Instead, it actually autonomously logs into your back-end database, changes the prices on the live storefront, and then continuously monitors the profit margins and customer click streams in real time.
Wow, yeah.
And it adjusts its own strategy on the fly. I mean, we are really moving from an era of AI that talks to an era of AI that acts.
Which is it's a massive paradigm shift. I mean, for the last few years, we've basically treated AI like an incredibly smart encyclopedia.
Right, a really smart search engine.
Exactly. You type in a prompt, you get text back. But the AI itself is, well, it's isolated. It doesn't actually do anything in the real world unless a human acts as the intermediary.
And that static relationship is breaking down rapidly.
Yeah.
I mean, we're moving past the hype of just generating text or answering trivia questions, and we're entering a phase where enterprise AI operates autonomously.
Yeah, completely autonomously.
So to understand exactly how this transformation is happening, we have a fascinating new article published today, May 12, 2026. It's by technology veteran Shish S, and it's titled From IoT to AI Agents: Why Sensors, Processors, and Actuators Still Matter.
The author brings a really unique perspective here because their entire career has been in IoT, the Internet of Things. And they've identified this incredible architectural overlap between the connected physical devices we use every day on factory floors and the most advanced digital AI agents being built right now.
I look at that premise and think, okay, let's unpack this. Welcome to the deep dive. Our mission today is to equip you with a powerful, practical mental model for understanding the future of AI. We're going to decode how the architecture used for things like, smart thermostats and industrial robotics is secretly becoming the exact blueprint for modern AI agents.
What's fascinating here is that this isn't just some niche theory. The author points out a recent conversation between Andrej Karpathy and Sequoia Capital that completely validated this exact framing. Yeah, the leaders in the field are realizing that arguing over which AI model has the absolute highest reasoning benchmark is, well, it's almost missing the point.
Interesting.
Because a highly intelligent model is essentially useless if it's not embedded in a larger system architecture, specifically a continuous operational loop.
Okay, I'm going to push back on that foundational idea before we get too deep into the weeds. Are we just slapping old industrial labels, sensors and actuators onto new software tech because it's a comfortable metaphor?
Right.
Or is there a functional structural reason this specific architecture is absolutely necessary for AI to progress?
It is a functional imperative. Intelligence, whether it's biological or artificial, requires context.
Okay.
And context is never static, right? It's constantly changing. Think about traditional IoT on a factory floor. You have physical sensors like a vibration monitor on a motor. It gathers real-time data. A processor interprets that data to see if the motor is failing, and then an actuator translates that decision into a physical action, like automatically shutting off a valve.
Oh, I see.
The AI agent requires that exact same continuous loop. Without it, the AI is just frozen in time. With it, the AI becomes an autonomous participant in a dynamic environment.
It's like AI is evolving from a brain sitting in a jar on a desk to a full digital body that can actually interact with the world.
Exactly, a digital body.
So if the AI is no longer a brain in a jar, and it now has this digital body operating in the loop, the logical first step is perception. How does it actually perceive its environment? Because every intelligence system has to start by taking in information.
Precisely. And this brings us to the sensor layer. Now, we all know what physical sensors are.
Right, temperature probes, cameras.
Yeah, LiDAR on autonomous cars. They maintain a continuous awareness of environmental conditions. But for an AI agent, the sensory layer is entirely digital.
The author gives some great examples of this translation. An AI retail agent isn't necessarily using a physical camera in a store. It's sensing the retail environment through live inventory feeds, point-of-sale systems, customer clickstream behavior, and social media trend signals. And a coding AI senses its environment through source code repositories, runtime execution traces, and compiler build failures.
And a business strategy agent is continuously monitoring live financial filings, earnings call transcripts, and internal operational KPIs. The underlying mechanism is exactly the same as a physical temperature probe.
Oh, wow.
The intelligence of the system is entirely bottlenecked by the richness and the real-time quality of those incoming digital signals.
Wait, I have to interrupt because here's where it gets really interesting. I can imagine someone listening to this and thinking, hold on. Isn't feeding an AI a spreadsheet of inventory data or a PDF of a financial filing just old school data entry?
Right, right.
How does that functionally act as a sensor?
Well, if we connect this to the bigger picture, the vital difference is between a static, one-time input and continuous real-time perception.
Yep.
Data entry happens once. You upload a spreadsheet to a language model, it reads it, and its worldview is instantly frozen in that exact moment. It doesn't know if inventory dropped 5 minutes later.
Right.
A sensor, however, is a live, persistent feed.
So it's the difference between showing the AI a static photograph of a crowded room versus hooking it up to a live security camera feed where it can see people moving.
Exactly. Systems built on static context behave very rigidly. Systems connected to continuous, real-time signals exhibit real adaptability. And to actually manage this fire hose of continuous data, modern AI architectures aren't just using simple file uploads.
Right, that wouldn't work.
No, they are relying on a complex digital nervous system made up of retrieval augmented generation systems, event-driven architectures, and vector databases.
Let's actually dig into that mechanism because people throw around the term vector database constantly. How does the database act as a sensory organ?
Think of a vector database not as a traditional filing cabinet where you search for exact keywords, but as a multidimensional map of concepts.
A map of concepts.
Yes, it turns ideas into coordinates. If the concept of heavy rain is at one coordinate, the concepts of umbrella sales and shipping delays live very close to it on that map.
So the AI isn't just doing a keyword search for rain.
Right, so imagine an event-driven architecture flags a sudden weather alert from a digital sensor. The AI agent immediately hits the vector database, and because of how those concepts are mapped, it instantly feels the semantic connection to its current inventory levels and logistical routes.
That's wild.
It is perceiving the environment and recognizing downstream implications in real time.
Which means the AI has successfully perceived the world, it has sensed the massive influx of data, and it understands the context. But sensing is only step one.
Yes, just step one.
What happens next? How does the AI turn that perception into a strategy?
That is where we move from perception to interpretation. We enter the processor layer. In early traditional IoT systems, the processor layer was fairly rigid.
Like basic if-then statements.
Exactly. You had basic edge compute systems running simple rules engines. If the temperature sensor hits 80 degrees, turn on the cooling fan. It was highly deterministic.
But modern AI completely blows the ceiling off that cognitive layer. Today's agent architectures are using large language models, planning agents, and reflective reasoning loops.
Yeah.
It's totally different from the prompt and response dynamic we're used to.
It changes the entire paradigm. Think about a pilot flying a commercial airplane. A pilot doesn't just check the altimeter once before taking off and blindly trust a flight plan.
Yeah, that would be terrifying.
Right. It's a continuous feedback loop. They push the throttle, which is the actuator. They feel the physical lift of the plane, the sensor. They check the altimeter again, calculate the trajectory, and adjust. The processor layer of an AI agent works exactly the same way. It maintains state over time.
So we are moving away from treating AI like a magic 8-ball that just answers isolated questions to treating it like a chess master that is continuously evaluating the board and planning 5 moves ahead.
Yes, exactly. And let's look at a concrete example of this to show why the closed loop is so critical at the processor layer. Let's compare a broken loop coding AI with a closed loop coding AI.
Okay, I like this.
In a broken loop, or an open loop, you tell the AI to write a Python script for a web scraper. It generates the code. It stops. The loop is open.
Right.
If there is a syntax error, the AI has no idea. It requires a human to run the code, see the error, copy the error, and paste it back into the prompt.
The human is acting as both the sensor and the actuator in that scenario.
Exactly. But in a closed loop, the AI agent writes the Python script. Then it uses an actuator to run the compiler itself.
Okay.
The compiler throws a syntax error. The AI uses a digital sensor to read that error log. The processor layer reasons about why it failed, revises the code, and acts again to recompile.
Wow.
It continues that loop autonomously until the code executes perfectly. The processor's role is no longer just generating text for a human. Its job is to continuously interpret the environment for the express purpose of deciding the very next action it needs to take.
And that leads directly to the execution phase. The AI has sensed the environment, it has reasoned through the problem, and it has formulated a plan. But reasoning, no matter how advanced or brilliant, is utterly useless if the system cannot physically execute the plan.
Which brings us to the final and frankly most disruptive piece of the operational loop, the actuator layer. In
Hmm.
physical IoT, actuators create direct changes in the real world. Motors rotate, robotic arms lift products, valves open.
Intelligence becomes tangible operation.
Yes.
But for AI software agents, they're using digital actuators. The examples the author provides in the source material are wild. We're talking about browser automation, API execution, and direct database updates. The AI is actually reaching out and touching the digital environment.
Take the supply chain agent the author highlights. It detects a massive weather disruption using its digital sensors. In the processor layer, it evaluates 5 different logistical alternatives and calculates a new rerouting plan. But it doesn't just email that plan to a human logistics manager. Using digital actuators, it executes APIs to update the procurement systems autonomously, cancels the delayed freight, books the new freight, and immediately begins monitoring the downstream effects.
The article also mentions a merchandising agent that can sense an inventory buildup of a specific product, process a new markdown strategy to clear the stock, and then use digital actuators to independently adjust the pricing on the live e-commerce website.
Yep.
I have to stop here because this sounds a bit intimidating. We are talking about letting AI turn the knobs and pull the levers of a business without a human hitting approve. Handing over direct database access to a language model sounds like an absolute security nightmare. What happens when the AI hallucinates and accidentally prices a $1,000 television for $1?
This raises an important question, and it is the exact fear keeping CIOs awake at night. How do you trust an autonomous system with direct operational control?
Yeah, how do you?
The answer, ironically, lies entirely within the closed-loop architecture we've been discussing. The loop is the safety net.
How so? Because if it already changed the price to $1, the damage is done.
Because the actuators are tied inextricably back to the sensors. The system is never acting blindly. Think about the $1 television scenario. The AI makes the price change. Because it is a closed loop, its digital sensors are instantly monitoring the live clickstream behavior and the revenue metrics.
Oh, I see.
Within milliseconds, it senses a massive, anomalous spike in sales, coupled with a catastrophic drop in profit margins.
It catches its own mistake.
It checks its own work. The processor evaluates that new, terrifying reality against its core constraint parameters, realizes the error, and uses the actuator to instantly revert the price or pause the product listing.
Wow.
If you just had an AI agent firing off API calls without a sensory feedback loop, yes, it would bankrupt a company. But the continuous feedback loop is what makes autonomous action viable, safe, and self-correcting.
Okay, that mechanical explanation makes perfect sense. But I want to take this theoretical model out of the clouds. Let's look at a practical experiment. The author actually put this entire architecture to the test in a real-world experiment they documented called I Let Agents Run a Retail Store.
This is where the convergence of IoT architecture and AI becomes incredibly tangible. The author was inspired by a real-world autonomous retail experiment from a group called Andon Labs, where an AI agent named Luna was given actual operational control over store management and merchandising.
So to test the thesis, the author built a distributed multi-agent workflow to operate an autonomous online retail pipeline, and they mapped it flawlessly to this sensor processor actuator model. For the sensory layer, they didn't just hook up a generic LLM, they built a highly specialized Scout agent.
Right, and the Scout agent's sole operational purpose was continuous perception. It wasn't burdened with decision-making.
Yeah.
It monitored market trends, product popularity, and social content across the internet. It gathered the raw material, but it didn't just dump a massive text file onto the next agent.
Right. How did the handoff actually work? Because the processor layer wasn't a single monolithic AI model. It was distributed across specialized agents.
Exactly. The Scout agent took that unstructured sensory data, say a surging trend in neon green aesthetic on social media, and structured it into a specific data schema. It then handed that structured data to a workflow logic agent.
So that's the central nervous system.
Exactly. It routed the trend data to a specialized creative agent.
So the creative agent handles the actual product ideation, generating a design based on the Scout's trend data. But wait, what if the creative agent designs an image that is the wrong aspect ratio for the storefront? In an open loop, the process just fails and throws an error code.
But in this distributed cognitive architecture, the workflow logic agent senses the failure. It recognizes the resolution mismatch, sends a targeted prompt back to the creative agent to resize the asset, and verifies the correction.
That is amazing.
Different agents perform different forms of reasoning, seamlessly checking each other, just like a complex industrial facility uses different processors for different operational zones.
And then we hit the actuators. Once the workflow agent approves the final asset, It hands it off to a publishing agent. The AI doesn't email a human a cool idea for a t-shirt. It uses browser automation to log into the e-commerce platform, uploads the optimized image, fills out the metadata, and initiates the publishing sequence.
Yes, it does it all.
So what does this all mean? The AI wasn't just designing a cool t-shirt in a vacuum. It was sensing the trend, creating the product, and actually stocking the digital shelves.
And what the author realized from executing this experiment is the ultimate validation of the entire thesis. The quality of the retail store's outcomes depended entirely on the integrity of the closed-loop architecture.
It wasn't just about one smart model.
No, success was not about having one super smart AI model that could write a brilliant product description. It was entirely about how effectively the system of agents could sense changing conditions, pass that data accurately, interpret the signals, resolve internal conflicts, and adapt their actions continuously.
It proves, without a doubt, that the worlds of connected systems and AI are no longer operating in silos. The IoT industry spent decades painstakingly building the connective infrastructure, the protocols, the event streams, the API gateways that allowed the physical world to talk to the digital world.
Uh-huh.
And now, AI is stepping in to provide a remarkably rich cognitive layer right on top of that exact same infrastructure.
They are completely complementary. The intelligent enterprise systems of the future require real-time awareness, deep interpretation, and autonomous action. As the author points out, the tighter those loops become, the more adaptive the entire system becomes.
Wow.
We are transitioning from software that simply manages human workflows to systems that actually do the work themselves.
So bringing it directly back to you, listening to this right now, whether you are prepping for a tech strategy meeting, trying to optimize your own workflows, or you're just intensely curious about the architecture of tomorrow, you need to start looking at your tools through this exact lens. Look at the software systems you rely on every single day and ask yourself, what are the sensors, what are the processors, and what are the actuators? More importantly, where is the loop broken and where is it continuous?
Once you start viewing enterprise architecture through this framework, you will immediately understand why some AI implementations feel like a clunky, frustrating gimmick, while others feel like absolute magic.
Right.
The magic is never just the model. The magic is a properly closed operational loop.
It changes everything about how you evaluate new technology. But before we wrap up, I want to leave you with a final, lingering question to mull over on your own. We spent this entire deep dive exploring how AI is currently mastering digital actuators, automating web browsers, executing complex APIs, autonomously updating live databases.
Yeah.
But if the blueprint for AI agents truly comes from the physical industrial world of IoT, what happens when this highly advanced digital cognitive layer fully merges back into physical IoT actuators?
That is the true frontier.
Right. What happens when the AI isn't just updating a supply chain spreadsheet, but is dynamically and autonomously operating the robotic arms in an Amazon warehouse, adjusting the physical HVAC valves in a Manhattan skyscraper, or routing the traffic grids in our major cities in real time?
It's coming.
We've finally given the brain and the jar a highly capable digital body. But are we truly ready for a world where our physical environment is dynamically operated by autonomous reasoning agents? Something to think about. Thanks for joining us on this deep dive, and we'll catch you next time.